This class, I was telling that whenever you have an L and C in your circuit, you will definitely have this term quality factor coming into picture. So we are very much interested in finding out what is the quality factor of inductor, what is the quality factor of capacitor, to assess whether efficient conversion of energy takes place between L and C. You know, L stores energy in magnetic field and C stores energy in electric field, right? So in order to ensure that the signal transfer between L and C is very efficient, we want to see what is the quality factor. So quality factor is determined only for energy storage devices and are not energy dissipating devices. So we don't find quality factor for resistor. We find quality factor only for inductor and capacitor. And this quality factor is found at a particular frequency. Okay, the quality factor is found at a particular frequency. So in ideally, inductor will not have any resistance. So you represent inductor just by a symbol of inductor. But practically, you see, inductor will always possess a small resistance in addition to its inductance. So we always represent the practical inductor having a series resistance like this. And this resistance value will seriously affect the quality factor of your inductor. So as small as this resistance value, the Q value will be very high for the inductor. Because resistance value, if it is large, it will start dissipating more energy, and energy storage of inductor will reduce, which will reduce your Q factor also. Okay, so practical inductors are represented by L in series with R, and this R has to be as small as possible for the quality factor of the inductor should be to be very high. And this is the standard definition of quality factor. It is mostly asked in the end semester exams. So write the expression for quality factor of inductor or a capacitor. So generally, quality factor of inductor at an operating frequency omega is defined as, I told you yesterday, Q is equal to ratio of impedance of the coil to its resistance. I can generally say it is X by R. One formula is Q is equal to X by R. It is not impedance, it is actually reactance of the coil. Q is equal to X by R. It is one formula involving the resistance and reactance. One more formula is involving the energy storage and dissipation cycles. So Q is equal to 2 pi into maximum energy stored per cycle by energy dissipated per cycle. So, however way you are going to find the quality factor for inductor or capacitor, you will be ending up with the same expression. So, two formulas for Q are there. One is Q is the ratio of reactance to the resistance, and the other formula is Q is 2 pi into maximum energy stored per cycle divided by energy dissipated per cycle. So, we are going to find the Q factor of inductor, capacitor, using the formula whatever we have seen now.